Hello everybody, this is a fiendishly difficult problem for Unit A4 of IB Physics. So it's for the HL content only and involves pulleys. There's actually three different ways to solve this. So here is the problem. You've got two blocks of mass m and 2m connected with a massless spring that goes over a pulley of mass m. Therefore, when the blocks are released, it's going to accelerate clockwise. The pulleys turn around the axle, that little white crossed bit in the middle there, as the blocks move. The string doesn't slip at all, so it's moving with the pulley. The radius of the pulley r and the moment of inertia of the wheel, the big grey wheel there, is half mr squared over 2. And what the question wants you to solve is show that the acceleration a of the blocks is given by 2g over 7. Very difficult problem. It's from a fairly recent IB Physics paper, and three different ways to solve it. It might take some time, so feel free to pause and come back to the video. Otherwise, here's the solutions. So the first one, we're going to use conservation of energy. So taking our blocks, let's think about the changes in energy a minute. Initially, everything is static, and then mass 1, the little one, will move upwards with kinetic energy, mass 2 will move downwards, but we're also going to start turning the wheel, so there's angular kinetic energy there as well. What is the result of all this? Well, we're going to end up with some movement of the wheel, okay? That's going to result in effectively a change in the height of the two masses. So we can set this up because we know that energy is conserved, so the change in height of the two masses in total will be 2mgh minus mgh, because the masses will be, if you think about the mass distribution of both of them, it's going to move down just slightly, mgh. Angular kinetic energy plus the kinetic energy of the little mass going up and the big mass going down. We don't need to worry about vectors here. Kinetic energy is not a vector, it's a scalar. And we, from our formula booklet, angular kinetic energy is half moment of inertia times angular velocity squared. Substituting that into the formula gives us this, okay? So what we can do is multiply everything by 2 and realize that omega, v, because v equals omega times r, then omega squared equals v squared over r squared. So that gives us a nice substitution there. So what you see in this next expression is we've substituted in for the moment of inertia, we've substituted for omega squared, and now if we multiply, oh sorry, my mistake, animation trauma here, we get rid of the r squareds, multiply both sides by 2, and that gives us this expression. Then the next thing we're going to get up to is cancelling all the masses, simplify things a little bit. This leaves us with this. So we've got v, half v squared plus 3v squared equals 2gh. And because 3.5 equals 7.5, that's where the 7 comes from. It confused me a bit when I first saw this problem. So that gives us 7/2 v squared equals 2gh. A little bit of trig here, and we not trig, a little bit of algebra, and we end up with v squared equals 4gh over 7. Now at this point, what you're going to have to do is answer the question, and we're getting closer, but then we need to tie this into an equation of motion. And because the initial velocity is 0, u squared goes bye-bye. So that gives us v squared is equal to 2as. From there, it's pretty straightforward to realise that the displacement s and height both are distances that cancel out. After that, it's just a simple matter of pushing around the numbers and we end up with our expression here. Okay, so that's one way of doing it. The next way is using forces, a little bit trickier. None of these ways are particularly easy. The force is acting on the block 2m, there's tension going up the way, and there's 2mg going down the way, and that is equal to the resultant force, 2ma. Then the force is acting on the little mass going up the way, tension is going to pull it up the way, the weight of mg is going to go down the way, and that will give us ma. So we know that the torque, the turning effect of the force, is moment of inertia times the angular acceleration. So that gives us our tau is the force times the radius, and the resultant force is T1 minus T2. Okay, it's a tricky one, that one. And then we use our same moment of inertia and the fact that the angular acceleration is linear acceleration divided by the radius, similar to the sort of v omega r equation, just with acceleration applied with finding the derivative with respect to time. Now, cancel our r's on both sides, leaving us with this, and then we go back and rearrange the first two equations that we derived earlier. Okay? From there, that allows us this expression. Just be careful with the signs in T2, because they're reverse, thanks to the minus T2. And when we add all of those up together, all the mg's, all the ma's, what we're left with, once we cancel m's as well, make things a little bit simpler, something like this. And you can see it's kind of going along the same path as the first method. From there, that gives us g is equal to the same sort of 3.5 a's is 7 halves of a, and rearranging that gives us our the expression we're looking for in the next place. Same thing. That is pretty disgusting, pretty difficult, and I would be amazed if anybody got this first time. It was in the IB paper 2, HL paper, and yeah, that would have got me stuck. I think it was only 3 marks, maybe 4. Anyhow, moving on. Here's the next one. We can use moment of inertia, because moment of inertia is a sum of all the masses in the radius squared from an object. So here we go. Pulley, we know that's already mr squared over 2, or half mr squared. We've got the mass m, and that's just going to be mr squared. And then we also have the mass 2m, which is going to be 2mr squared. So when we find the sum of all the moments of inertia, it gives us 7 over 2 mr squared. Taking this and using force, or sorry, turning effect of the force tau equals Fr, or mgr, we can start throwing that into the sort of Newton's second law for angular motion. And then we're simply going to substitute for tau, mgr, and then moment of inertia, 7 over 2 mr squared. From there, cancel out the m's, cancel out the r's, and we're back to here. All we're doing then is rearranging to get the same answer once more. None of these are particularly easy. Well done if you managed any one of them.